Hey guys, welcome to section 3, chapter 6 of the geometry program. And in this section, we're going to be dealing with whether quadrilaterals are actually parallelograms or not. So we're going to have several theorems here that we're going to need to write down, so get your pencil ready. The first that says that the diagonals of a parallelogram bisect each other. All right, so remember from our discussion in the previous section, a parallelogram is a four-sided figure where opposite sides are parallel. So you have two sets of parallel sides. And then this theorem tells us that when you look at the diagonals, they actually split themselves into equal segments. So this part of the diagonal is congruent to that part of the diagonal. That's what it means to bisect, right? Is to cut in half. And this piece is the same as this piece. So that's our first theorem, that the diagonals bisect each other. All right. Next up, theorem 6.5. So if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So now if you only have information about one set of sides, but you know that they're parallel and also congruent, then you know that the shape has got to be a parallelogram. So it's okay if you don't know that the opposite sides, you have two sets of parallel sides. But if you do know that one set is parallel and congruent, then you can know that it is a parallelogram. All right, I'm trying not to go too fast, but pause the video if I'm going too fast. Theorem 6.6, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So say you don't know anything about whether they're parallel to each other, but you do know that x is congruent to x and y is congruent to y, right? So this is congruent to this and this is congruent to this. Then you know that it has to be a parallelogram. So if you know that opposite sides are congruent, then it's a parallelogram. All right, a final theorem here, 6.7. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So now we're just talking about angles. So if this angle is congruent to this angle and this angle is congruent to this angle, then you can also say that this figure is a parallelogram. Okay, so now we're going to jump into some examples. For the next two shapes, we're going to assume that the shapes are parallelograms, and we're going to apply these theorems. So in this first example, we know that the shape is a parallelogram, and our first theorem told us that the diagonals of a parallelogram bisect each other. So what that means is that this piece is congruent to this piece. In order for us to solve for x, then I simply have to put these two pieces equal to each other and solve. So if I move 12 to the left and I subtract 2x from the right, then I'm going to get x equals 3. All right, you're going to get a little algebra review for some of these problems, but hopefully that won't bother you too much. All right, similarly in this guy, we know that the shape is a parallelogram, therefore the two pieces of the same diagonal have got to be congruent. So 2y plus 3 is equal to y plus 7. And then you can just solve that for y. So y is going to equal 4. And it's really just that easy. Okay, an extension of that. Let's say we wanted to solve for both x and y here. Okay, I know that my one set of diagonals, x has to be equal to 2y, but that has two variables, so I can't solve for either one of those yet. But if you look at our second set of diagonals, we have 2x plus 14 equals 5x minus 4. And now we can solve. If I subtract 2x from the right and I add 4 to the left, then I know x has to equal 6. And once I know that, I can make the substitution back into this equation. So 6 equals 2y, therefore y has to equal 3. So sometimes you just have to recognize the information that you have and make sure you're setting it up before you can recognize, okay, I can't solve the first one, but I can solve the second one, and then go back and plug it in. All right, then one of our theorems said that the shape is a parallelogram if one set of sides is both parallel, which we have denoted here, and also congruent. So how can we prove that this is a parallelogram? We can prove that 4x plus 20 is equal to x plus 26. And if you subtract x, you get 3x, and if you subtract 20, you're going to get 6, so x equals 2. So that would prove that this shape is a parallelogram. All right, almost done, believe it or not. All right, let's say you needed to solve for x and find the length of TR. All right, so we talked about how in parallelograms the diagonals bisect each other, which would mean that 2x plus 3 has to equal 15. And then 2x would equal 12, and x would equal 6. All right, well, it also asks us to solve for TR. Well, TR would be 15, the value of 15 plus the value of that 2x plus 3, right? So TR would be the first diagonal plus 2 times 6 plus 3. And in case you didn't guess it, TR has to be 30. And of course, you could have known that to be true because the diagonals bisect each other, right? So this value also has to be equal to 15. Some of them won't be so obvious, like maybe this one. I always have to throw in one hard one. Okay, so let's say we wanted to find the value of ln. And what they give us is this short diagonal LE, and then they give us the whole diagonal LN. Well, I know that this piece here also has to be 5x plus 3, right? Because the diagonals have to be congruent in a parallelogram. I'm sorry, the diagonals bisect each other, meaning the segments of a diagonal are congruent to each other. So then I could set this up like an algebra problem. I could take my first piece, 5x plus 3, add my second piece, 5x plus 3, and know that the whole thing has to equal 13x minus 3. All right, so now you have a slightly more advanced algebra problem here that you guys can solve, I'm sure. All right, so then I'm going to subtract 10x, and I'm going to add 3, so x equals 3. Now, you're going to say, okay, done, moving on. But wait, you didn't actually find ln. All you did was solve for x. So be really careful with your directions. Now we have to plug this back in. So 5 times 3 plus 3 is 15 plus 3, which is 18. That's the value of one of these pieces of the diagonal. But of course, this has to equal 18 too, right? We have 2 pieces. So then really, the length of ln has to be 36. Right? So we had to plug in the x, make sure we get both pieces of the diagonal, add them together to find the length of ln. So your homework is going to include some of these types of problems. I don't think today, but maybe tomorrow. So just be really mindful of what the directions say. Make sure you're finding what they're asking you to find. All right, when you're ready, go ahead and finish up your notes, read through the examples, and begin your assignment.